Yeah, Donald suggested. This is going to be the weirdest ever intro by a speaker at Ratio Christi. I'm showing this video before Grayson mentioned, yeah, my schedule's a little tight. This is where I usually am. I am watching my daughter, who is an American Ninja Warrior, win world championships around the world. This one was in Croatia last fall. That's cool. And
it's no surprise that two ladies who trained in the same place, in the same state, with the same coaches.
Listen, we see this all the time at NCR. Colorado.
This is on an island off of the Croatian coast last October.
Well, if you build it, they will come. And if it's Colorado,
1,000 spectators on the side of a medieval hallway.
I've never seen this intensity on Jaleesa's face.
Look who she's going up against.
Best on best right here.
Oh, and she switched it on. Elizabeth switched it on. You saw the light in her eyes and she sprinted off.
Both of them with a lightning fast start. And Elizabeth Popkos just parked. Now, Jaleesa missed the bell. Jaleesa had to make that one move.
I thought Elizabeth missed the bell and it was Jaleesa.
Jaleesa had to do one move to maintain pace and she missed. And now it's Elizabeth Polsgrove, 13 years old, volleyball player, just a baby, running up the ball. Huge smile. She is your Croatia Spartan 100-meter champion, the youngest champion we've ever had in the history of 100-meter OCR.
Let me say something about this run.
That's my life, usually. But I'm actually going to use my education and talk about a topic I've found fascinating since I was your age and help propel my faith and my spiritual journey, let's say, over many years, now decades. I just turned 50 this last January. And so I gave this talk here at Ratio Christi for the first time in 2020. It wasn't here. It was from my back porch. Because we couldn't meet. So
Yeah.
lucky. We're going to get to be together now. I know you guys are in high school or middle school or whatever. But yeah, so the idea tonight is nerding out about space. So I hope you guys like space and astronomy. That's my thing. I think it's an amazing way that God has revealed his presence and influence on the universe as the creator. There's the title. Is the universe fine-tuned for life? Is Earth unique? What model best explains the data? Chance, necessity, or design? Just curious, has anybody ever heard that word fine-tuning before? And willing to raise their hand? Okay, close to me. Cool. Well, just a quick, here's me in a nutshell. I always like to learn a little bit about speaker before they go into the details. I grew up in Michigan, Detroit, right about there. I love sports way more than anything else, but I got good enough grades to go to college and go to the Air Force Academy. So it's a weird connection with my grandpa. Grayson said his grandpa is who alerted him to the Colorado School of Mines despite growing up in Texas. My grandpa was in the Air Force in World War II. And so I was aware of the Air Force and then this weird tiny military academy in Colorado despite growing up there. It's like, yeah, I'll apply. Worked out. Got to go there. There's me, like as a freshman. And then while I was there, I majored in physics with a concentration in astronomy for my undergrad at Air Force. And at some point, I had grown up in the church. I was saved at age 10. And I went to a church that was kind of like Baptist. And I didn't really focus much of my attention on cosmology or science as a kid growing up in high school. But I now know is just a kind of not forced on, but kind of a young Earth view of the universe and creation. And as I got into my physics classes and was presented with, and biology and stuff, presented with the evidence of the Big Bang and like radiometric dating and stuff, and I was like, yikes, this feels really incompatible with the 10,000-year-old universe. And thankfully I had a mentor. I was in the Navigators on my ministry group on campus, and my kind of mentor, Bible study guy, introduced me to Reasons to Believe and this book called The Creator and the Cosmos. I even have a copy of it right here, right now, by Dr. Hugh Ross. And I was really impressed by, and to today am a proponent of the old Earth creation model, if you will. The Big Bang data is strong, but God did it. And so that was a very formative time in my life when I was about your guys' age. Went on to go to grad school at Michigan State, got my master's degree there in astrophysics, and then later I had to go in the real Air Force for a while, and then they sent me to Minnesota for a PhD in astrophysics. So I got to go there for 3 years, grow out my beard and stuff, not wear a uniform. It's pretty sweet. And I studied the Big Bang Theory. Actually, I was in the observational cosmology group. I worked on a lot of electronics, calibrating a telescope that is sitting under that huge balloon. It eventually flew over Antarctica. Got data on the cosmic microwave background radiation. And didn't really produce too much. Because somebody made a bad calculation on how much heat the motor to make the telescope go up and down could take at 120,000 feet above sea level, or above the ground. And it broke an hour into $7 million and 12 years of effort down the drain, but that's experimental astrophysics. Here's my life now. My wife and I were both in the Air Force. We got 2 kids. That's my son. He's a soccer player. There's Liz doing her thing in Costa Rica a couple years ago. So I was visiting Michigan. I have 2 part-time jobs. I teach astronomy at a high school near my house in Colorado Springs called Ascend College Prep a couple days a week. And I also lecture at the Air Force Academy Planetarium. Here's where you pull out your phones, and I get to calibrate your knowledge of today's topic before beginning. Wow, there's no hesitation. You guys are like, I'm ready. Okay, so I gotta switch modes here for a second. I discovered a few years ago a free piece of software called Poll Everywhere, and hopefully it will work, but it will not because I'm not on the internet. I should have thought of that. What can I do? Mine's guessed? Yep. Sweet. So what will happen is this website will come up, and then I'll be able to press play, and you'll be able to log in.
You need to
Not
press
sign up.
accept on the website, otherwise it
Oh, you
doesn't.
gotta do that. I always miss this piece when I come up here. Sorry. If it works, it works. If it doesn't, it's not a big deal. Which it doesn't look like it's working on. Any thoughts, Grayson?
Maybe try reloading the page.
Okay. Cool. Yeah, we can come back to it later. Doesn't look promising.
No.
Oh well, that would have been fun.
And maybe try closing the tab and trying to connect again.
It's still showing no internet.
Yeah.
Try to disconnect and connect.
Wait, how do they pull up all those tabs with that internet?
Exactly. They might have already been up. I guess just sitting there, latent. It doesn't like all these tabs open. Oh well.
It's worth a shot.
It was worth a shot. I also had, I had a video clip to show as well. That clearly is not going to work, so I'll just pretend like it's working and tell you what this YouTube channel showed. And the title of this little clip at the beginning of this 20-minute thing was titled, "The Argument for God Atheists Fear the Most." And as you can probably guess, what's great out there is the words fine-tuning. The fine-tuning argument. So at the beginning of this, I hadn't even ever heard of this web or this YouTube page. It's called The Council of Trent. That's pretty funny. So this guy's name is Trent. He's an apologist, and he shows where there's clips of some famous atheists, Richard Dawkins and Christopher Hitchens, being quoted like on camera saying, you know, obviously we think there's no God, but of the many arguments for God, the fine-tuning version of the design argument is the most compelling. If I were to be converted, it would likely be because of the fine-tuning argument. And so, I'm going to try to demonstrate by way of articulating that argument and interesting aspects of it. And you guys can decide how interesting you think it is. You've all heard of the fine-tuning argument, so this may be review. But hopefully some new nuggets. So here's the flight plan. I had to throw in a little Air Force ease, of course. So we're going to do definitions, fine-tuning, abductive, deductive, inductive reasoning. Part one will be of 2 parts. Actually, there's 3 parts total, but there's kind of 2 flavors of fine tuning, which I just made up. Universal fine tuning, so the fundamental constants of physics that have been discovered to date, about 31 of them between the standard model of particle physics and cosmological models. So like cosmological constant, the gravitational constant, electron mass, etc. Values and seemingly very tight tolerances that would permit life to be anywhere in this universe. The next one I call it locational fine tuning. It's more up my alley as an astronomer. Earth's potentially unique spot in the universe. Talked about habitable zones. You may have heard the word habitable zone or Goldilocks zone. Has to do with water. There's a lot more we've discovered in the last few years. Galaxy, about our star, our moon, the unlikely and maybe just right to allow life aspects of our planet. Then finally, competing interpretations and explanations. We've got theism. A God did this. We're a Christian group, so the God of the Bible is our answer. But it's fine-tuning implies intention and purpose, and the universe appears designed. Versus naturalism. Fine-tuning is better explained by chance or necessity. And we'll see your call at the end of whatever time we use to do this. So the fine-tuning argument is actually a subset of a larger umbrella term called teleological or design argument. And there's a few versions, like there's this one's called analogical design. And Paley's watchmaker argument is the best example. Anybody ever heard of that before? Claire, you ever heard of the watchmaker? Paley's watchmaker. Grayson, you heard of it?
I have.
Tell everybody what it is.
I think if I remember correctly, the argument goes like if you're walking in the forest and all of a sudden you look down and you see there's this pocket watch that's just sitting at your feet and it's working, it's operating, and it's even might have the right time on it. You don't suppose that all the factors around you and the natural causes surrounding you combine together to create this pocket watch. You assume that someone was walking and they dropped it, and that pocket watch was designed by someone, and somehow it wound up there.
Perfect. Great job, Grace. I knew you'd come through on the spot. We didn't even plan it. Yep, that's Paley. Is in the 1800s. Came up with it. And by analogy, the universe is simple. There's a purpose and seeming intent to the universe, so it was probably made by somebody outside of it. There's biological design. This would be Carl's area. Has done and will do in the future, I'm sure, talks that are relevant to that. Now, just outstandingly complex, even the simplest cell is, and how that's most likely the result of a super intellect than chance. Aquinas' fifth way is just a weird one where back in, I don't know when he was around, 1400s, 1300s, and suggested in this fifth, he had obviously 5 or more tenets that he wrote about, talked about, of unintelligent things like planets and stuff move around in seemingly purposeful ways, was the essential of that. And then there's here, this fine tuning is another one under this umbrella. That will be the focus of tonight, and has gained a lot of traction as astronomical and physics research has exploded over the last 50 years. What does fine-tuning really mean, though? Here's the definition. So it's simply a contrast between a wide range of possibilities and a narrow range of a particular outcome or phenomenon. It's actually philosophically neutral and doesn't mean that an agent has carefully crafted something. So we don't jump immediately even to the word design or God until a little further down the line. And then here are the 2 pieces of questions that we're going to try to answer. Are the initial conditions, laws of nature, and physical constants of this universe fine-tuned to permit the existence of life in this universe? I won't discuss the initial conditions or laws of nature much, just the physical constants. This could be a 10-hour talk otherwise. And then, if so, what's the most likely or best explanation for this fine-tuning? That's the goal. So lots of papers written about this and discoveries made that this is a subset of constants that I bet many of you have seen in classes here. At least some of them, maybe all of them. Anybody got a favorite? You got a favorite? What's your favorite, Grayson?
Electron mass.
Oh, yes. Electron mass. Yes.
Strong nuclear force.
Strong nuclear force, yes. Oh, they're all great. Here's another just way of putting it. This chart just has another subset of these, but I just threw it on there to highlight the extraordinary precision with which humans have determined these things at this point. The year 2026 BCE or CE. There's a few more of my favorites, like the Rydberg constant and the fine structure constant on here, but there's 31 total, so says the internet, between the standard model of particle physics and the standard model of cosmology. So what I'm going to do is I'm just picking 3. Good speakers always just pick things in 3s, right, Donald? So one is the mass of the neutron versus the proton. We're going to start from less fine-tuned to the most craziest fine-tuned of these 3 that I picked. So it is a measured fact that the neutron is about 0.138% more massive than a proton. Because of that, there's 7 times more protons than neutrons formed in the early universe. Now, an aside, I just said early universe. This obviously not accepting the Big Bang makes this irrelevant. This whole, actually the rest of the talk. So I'm just assuming that that model is accurate, and because of that slightly greater mass and the cooling of the universe in the early universe, this is the result. And you can kind of see in everybody's favorite units of mega electron volts per c squared, the relative masses of those 2 particles. Of course, it's because of their internal quark nature. So the fine-tuning of this is 1 in 10 to the 3rd, 1 chance in 1,000. Or if this was off by 0.1%, then there would be pretty catastrophic consequences for the formation of the building blocks of our universe that are required to eventually end up with life, namely stars, galaxies, and planets. It's really the kind of the punchline here throughout the next few slides. So if the neutron, a little more detail, if the neutron mass were bigger by 0.1%, 1 part in 10 to the 3rd, there would have been too few neutrons in the universe to ever form the life-essential heavy elements. And that's a claim that I'm just throwing out there at you, and I know you guys come mind, so you always think, how do you know that? I hope that's what you're thinking. I know that's what I do. I have, but we now have supercomputers, right? We can like run simulations. We can replicate the early universe with the laws of nature and put in different numbers and actually see the results. And people do that, right? Grad students are getting paid all over the world to do that and write papers and hopefully make tenure. So that's why I at least have confidence that this is probably true. Then, if the neutron mass were smaller by that same amount, 0.1%, this process called beta plus decay, where protons build into neutrons, would be too fervent, and there would be so many neutrons that all the stars in the universe would rapidly collapse into neutron stars and black holes before you could ever get a stable galaxy or stellar system and a planet and life. That's one example. Number 2 is the actual strength of gravity versus the electromagnetic. I'll bet you, I know Claire is going to have nightmares about that one, right? Physics 1. You got there yet?
They haven't brought it up yet.
Oh, just wait, you got a
That
month
might
left.
be this week's studio.
Is it really?
Probably.
Newton's law of gravitation, G times mass over distance squared, and that big G is the universal gravitational constant, identified in the 1600s by Newton himself. Now measured with extraordinary precision, 6.67, I think it's like 295, times 10 to the negative 11 Newton meters squared for kilograms squared. And then, of course, you'll see this next year, Claire in Physics 2, the electromagnetic force with Coulomb's constant, the K, charge 1, charge 2 over distance squared. Amazing. Just look at the form of those 2 equations, are identical. Right there, it's fishy. Somebody must have made this up. But the K and the G, what's wild when these are discovered, K is 10 to the 9th. G is 10 to the negative 11th. That is a 100 million trillion times difference. What? Again, run computer simulations about stars and the universe writ large, and you find that G, if it were changed by 1 part in 10 to the 40th power, trouble. If G were bigger by, I counted them too. I think I got the right number. 0 is 38 zeros. Percent. Gravity, when we talk about universal dynamics, gravity will beat dark energy, the expansion force of the universe, and the universe will collapse before stars, planets can form. And then even if we did get a universe and we got stars, if G's a little teeny tiny bit bigger, the stars will burn hotter and faster and they'll die. They'll go through their whole cycle and die out before you'll ever get a planet nearby that could ever have life. So those are a couple bad scenarios. And then if G were just a little bit smaller, and I only mentioned the universal consequences on this one, then dark energy expansion rate will beat gravity and the universe will expand so quickly that gas and dust clouds that have had the chance with this force of gravity to make stars, galaxies, and planets, it will never happen. And so we won't get any life. And finally, the granddaddy of all, only discovered in the last 28 years as research on type 1 supernovae in 1998, the year I graduated from the Air Force Academy, came out. The cosmological constant. It was actually invented in the 1920s by Einstein. And this is everybody's future favorite equation. Now, hopefully none of you ever are subjected to that equation in your life. But it's Einstein's field equations of general relativity. And when he first concocted it, it didn't have this term. And then because he was philosophically committed to a static, forever existing universe, he had to add a term to make it happen. He ended up calling it his biggest blunder of his career. But then ironically, 40 years after his death, data on type 1 supernovae revealed, oh, that term really should be in there. And that lambda is the cosmological constant. In absolutely meaningless to any of us numbers, there's the value calculated today with, again, crazy units. In this case, giga-electron volts per cubic meter. Awesome. But you can see tiny, extraordinarily tiny little number, but not zero. And that's what shocked the community. There was expectations that it should be zero, but then it wasn't. But it's outrageously small. And speaking of outrageously small, it's fine-tuned to 1 part in 10 to the 120th power. There are 10 to the 80th power atoms in the entire universe. Thus, this is 10 to the 40th times more odd or unlikely than walking around the universe and picking out one specially marked atom. I got the right numbers, zeros there too, I think. So anyway, if that lambda, that cosmological constant, that dark energy expansion forcer were that much bigger, again, the universe would expand too fast, gravity would never be able to overcome that and form galaxies, stars, planets, and life. Whereas if it was too small, gravity would win. And the universe would have collapsed in on itself before we get any of this stuff. So there's that 3 of 20-some that are just like that. The 1 in 10 to the 1/20th is the craziest. And those facts, as they were revealed through the last, 50, 80 years, inspired some very famous atheists and agnostics to make the following comments. The first one is Sir Fred Hoyle, maybe most famous for coining the term Big Bang on a BBC radio show in the 1940s when the idea was still being debated between two sides. Hoyle's like, oh yeah, like the universe just popped into existence in an explosion like a Big Bang. He was being totally condescending. Trying to make fun of it because he didn't think it was true. But then, he also said this, common sense interpretation of the facts suggests that a super intellect has monkeyed with physics as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. That's an atheist. Another famous atheist, Stephen Hawking, in the 80s, assessed the data and said this, the laws of science as we know them at present contain many fundamental numbers, like the size of the electric charge, the electron, oh, somebody's favorite, and the ratio of the masses of the proton and the electron. The remarkable fact is that the values of these numbers seem to have been very finely adjusted to make possible the development of life. Finally, more recently, Paul Davies, he's a famous author, scientist, 2006 says, there's now broad agreement among physicists and cosmologists that the universe is in several respects fine-tuned for life. But the conclusion is not so much that the universe is fine-tuned for life. Rather, it is fine-tuned for the building blocks and environments that life requires. The whole, we won't ever even get a planet because we won't have atoms if these numbers are not finely tuned in these super narrow ranges. So there's that question I had on a previous slide. Are those constants fine-tuned to permit the existence of life in the universe nearly unanimously, regardless of worldview? Theist, atheist, anything in between? Yeah. There's a few who try to contest these numbers aren't fine-tuned. But almost everybody, at least legitimately, says, yep. So here's part 2. What's the most likely or best explanation? There's 3 main options that if you're researching this, you'll find. Chance, necessity, or design. The first 2 are in the atheist camp because they don't require divine influence. Design is the theistic or God hypothesis, if you will. Maybe some more definitions though. I'm going to throw these at you. Because what in the world, what features of an object or phenomena would even indicate design? There's 3 of them. Contingency. It didn't have to be there, like a phenomena or an object. It didn't have to be there or be that way. This thing is not necessitated by law or chance. Then 2 is complexity, a low probability of occurrence. The arrangement of this thing or phenomenon is ordered and not arbitrary. And then finally, specificity, non-repetitive, high information patterns serving some discernible intended purpose. Man, it's a lot of annoying long words. Put this one up for Donald because he loves hiking. You see these all the time, right? Out on the trail. Well, maybe not lately because you're injured. How do you pronounce it? Cairns? Cairns? Okay. Anybody else hike around? You're in Colorado. I know you don't have time.
Well, it's been
Students, you
winter.
don't have time, right? I don't have time either.
I will be doing a lot in summer.
Good. Well, you'll see these, right? When you come upon that, I'm sure you walk by and you're like, wow, interesting how the wind picked these up. And they ended up stacked up right here. That probably just happened by chance. No, right?
No.
You know it had to have been a human being, probably, that did that. And that is not a super complex thing, but it has specificity. What's its purpose? Trail marker. To help you stay on track. It's intended from one human being to another. Intelligence to another. Come back to that, Karen. So for theism, the fine-tuned physical constants have sufficient contingency, complexity, and specificity, with the intended purpose being a life-permitting condition somewhere in this universe to make design the best explanation. And there's multiple approaches to making that conclusion for the theistic perspective. More big words, but I thought it's rational Christi. I gotta go there, right, Grayson?
Oh yeah.
Oh yeah. So abductive reasoning, which is represented by a couple. Obviously, there's lots of people in each of these camps, but some famous ones are Stephen Meyer and Michael Behe and the intelligent design communities primarily. And this is inferring the best explanation from the typically limited or incomplete data available. And so theists would infer that this is God that did this because it's the best explanation. Not a guarantee. It's not a slam dunk or a proof, of course. Then there's deductive reasoning, which Dr. William Lane Craig is at least credited with kind of being maybe the most famous. And this, of course, all this is from the internet nowadays. The precise complex conditions required for intelligent life, fine-tuning, cannot be explained by and are not necessary consequences of physical laws, necessity, or random occurrences, chance. Therefore, it's a guarantee. The answer has to be intentional design as the most reasonable explanation. So that's an example of deductive. And finally, inductive reasoning. And Dr. Luke Barnes, who's co-wrote a famous book called A Fortunate Universe, put it this way: given the observed order, complexity, and purpose in the universe, design is more reasonable or probable. They do a lot of probability calculations in that book with this method than the alternative of random chance or brute fact necessity. It seems really subtle. At least when I first read these, I'm like, what's the difference? There's little differences. Philosophers get PhDs in this, right? Kind of stuff. I've got a card trick. Has anybody ever done a card trick here?
I think this is the first.
First one ever? Okay. I'm gonna deal 5 cards. It's Wyatt. Okay. Wyatt, 5 cards. Then, who's back here? What's your name?
Hunter.
Hunter! Alright. And I'm giving you 5 because we're kind of simulating a poker hand. You guys play poker? You do? Okay. Check your cards. And you check your cards too, Hunter. What you got? We're not actually gonna play. You got a pretty good hand?
Yeah, Joe.
Good, yeah, join everybody. Since Wyatt plays poker, he knows. Is that a good hand or a bad hand?
Not great.
Not great. Okay. Hunter, what you got?
I have a. Don't remember what it's called, but I have a 10 jack,
Hold something?
queen, king, ace,
Show us, show Wyatt.
and the whole
Royal flush.
royal flush.
What?
Best hand you can get.
You got a royal flush.
Not even counting.
Gotta take Jack Hunter to the casino. Oh, that's ironic. So, why did we get excited about this and not so much about that? The odds are precisely the same of getting those 2 hands.
That one's unique. General one was not.
Was what?
Was not unique.
Oh, they're both unique, Don. They're both exactly the same uniqueness. Same odds of getting both of those hands. What do you think, Grayson?
That one has a specific meaning tied to it.
Determined that it is the best.
Oh, what? Who's determined that? You did?
Us humans.
Poker gods.
Like I guess the way I put it is there's special order, unnatural order. So when it just happens by chance, like whereas like the first one is like kind of what we would kind of expect to see.
Yeah, if it were random. Yeah, what do you think?
Like the people who wrote the rules decided that a royal flush is the best.
That's it. That's what I was going for. Some agent outside the realm of that card deck decided that meant a lot more importance than that. Could have. The 7-4-8 King 5 could have been the best hand in the universe. But it's not. That one happens to be. The cards are coming back shortly under the next phase, which is popular atheist objections and theist rebuttals. Everyone's favorite part. Hopefully, I assume in this group. This is a very small subset of what you can find on YouTube anytime you feel like it. But I'm here, so we'll talk about these. One is, chance is a perfectly viable explanation. There's 2 phases of this. One is, again, everybody's favorite. We live in a multiverse, probably. It's a natural outcome if cosmic inflation early in the universe is true. So with infinite or near infinite number of universes, one will eventually, inevitably, have initial conditions, laws, and constants that are life permitting. No reason to think anything's fishy. Or B, life permitting values for physical constants just as likely as any other set of values. No reason to be impressed or surprised that this particular set of values exists. All right. 1 in 649,740. Big whoop. So here's the rebuttals. For the multiverse, I mean, it's unobservable and unfalsifiable. Scientists talk about it all the time as if it's a scientific hypothesis, and it just really isn't. And you'll never convince somebody who's all about the multiverse that that statement's true. But it is. It's purely speculative at this point. It also defies Occam's razor. So you're trying to solve this problem, then you introduce an infinite number of other universes. So the idea of Occam's razor, which some of you may have encountered so far in school, is the simplest or least complex or least number of parts required to explain a phenomenon is probably right or preferable. This is the absolute end of the spectrum away from Occam's razor. And it also where does the multiverse come from? I gave a whole talk on the cosmological argument last year in this room. We would go there for that. But then for part B, the rebuttal of B, that set of values has specificity. in our case, with the constants of the universe, those constants enabled sentient beings able to observe and marvel at the unlikelihood of themselves existing. Any other combo of constants would yield no observers the royal flush has value over random hands because of rules created by an external intelligent agent. So if you're at the poker table, right away, that hand, you're playing, hey, worth nothing. I found a YouTube video, I just typed in biggest winnings on winning with the royal flush at World Series of Poker.
Wow.
3.4 mil. Guy got it. It was a pretty cool video. And he got somebody else to bet late too. Yeah. So then, speaking of royal flushes, you get 2 in a row. If you got 2 in a row, royal flushes sitting at the poker table. That's like 1 in 4.2 times 10 to the 11th chance. 3 in a row would be 1 in 2.7 times 10 to the 17th. If you got 20 in a row, you'd approach that cosmological constant odds. 20 in a row. Can you imagine the response of the onlookers, or the other players, or the dealer? Any rational person witnessing that would, of course, conclude this is cheating, rather than, wow, what a great streak of luck. What do I got next? The next one is the anthropic principle. Many ways of stating it. I just decided to put it in my own words like this. Hey, life is here. So the odds of it happening are 100%. I don't need any valid or reason to ponder the odds or question that outcome. A couple fun examples of this. All right, I'm going to flip this coin. Get this table to verify. Or make sure it doesn't here. What is it, Grayson?
That's heads.
Okay. What were the odds of that ending up heads?
Hopefully 50-50.
No, it's 100%. It ended up heads. Since it ended up heads, it's 100%. It happened. Right?
I was thinking it was 100% with those very specific initial conditions and that very specific amount of force at that very specific angle. But the odds of hitting that exactly every time.
I like that. It's true. I guess if you had all the information, you could have predicted that, couldn't you? It's good. Yeah. Of course, the point I'm trying to make is the anthropic principle seems a little preposterous to us when we put it in that context. And then the other really famous examples of a firing squad, this comes from an author called John Leslie, and he gave this little fake scenario where a squad of 12 marksmen are assigned to execute a prisoner. They're just a few meters away from the prisoner. They all line up, they take the shot, the prisoner opens his eyes, he's alive. They all missed. And the anthropic principle would make the following analysis of that event. It would say, well, if you'd been shot and killed, you wouldn't be around to be surprised or excited about not being shot and killed. Moving on with life. Whereas it seems ridiculous to us because the prisoner has every right and would be expected to find that outcome surprising. And instead of just thinking, wow, 12 military marksmen just happened by chance to miss me from 5 meters away, that some other explanation is definitely more plausible, like somebody switched out all the bullets for blanks before the marksmen picked up their weapons. Or they were all drunk. Or they were all bribed by one of his wealthy friends, unbeknownst to him. Some sort of intelligent agent acting on behalf of that prisoner rather than, wow, I got lucky. I guess it was inevitable. These are kind of a couple of the rebuttals. It is appropriate and intuitively obvious to question fine-tuning. Third is necessity. If you look up YouTube videos, Dawkins and others will state something like this. At times, it's not their go-to, but it could be that the values we observe for the constants are the only values possible. There actually aren't any knobs. There aren't seemingly infinite number of values that could be possible. Once we discover the theory of everything, it'll be revealed that these values were inevitable and or determined by a natural law or entity more fundamental than the space-time energy in our observable universe. So here's the rebuttal. These are my words. I heard somebody else use materialism of the gaps, but it's pure speculation, again, kind of like multiverse. And whereas Christians are sometimes accused of a God of the gaps argument, this is kind of a classic materialism of the gaps. We don't know, but we're gonna figure it out someday. Kind of like origin of life research, probably too, right?
Oh yeah.
Same thing.
Yeah.
I call it the
Despite
church
how
of
deplorable the evidence is. And we'll figure it out someday.
Figure it out someday. I call it the church of future science.
Yeah.
And then the second tenet was like, oh, there's some underlying law or entity beyond our physical universe. The physical universe actually isn't fundamental. Okay, if that's the natural world, you're saying then there's something outside nature, supernatural, that's responsible for this? You just posited God, essentially. All right, so now, and I'm going to fly through this second. So that was the universal constants, physical constants. We've got atoms, we've got planets, there can be life here. Now, we really live here on Earth, and it's kind of crazy. And we're finding how unlikely that is all the time. Main proponent of you're an idiot if you think we're alone in the universe is Neil deGrasse Tyson. He'll say stuff like, it's statistically ridiculous to think we're alone. We have charts all over the internet about potentially habitable exoplanets that have been discovered in the last year by the James Webb Space Telescope, etc. And the estimated number of habitable planets in the universe, I just decided to Google that and show you what AI comes up with, which of course is an aggregate of real information and papers and stuff on the internet. 300 million to 60 billion in our galaxy alone. Habitable. There's only 200 or 300 billion stars in the whole galaxy. So, what's the real story here? Is it really like we're pedestrian? The Earth is just very common, that there's probably life everywhere, or not? So what I like about the locational, besides it's about astronomy, because I love astronomy, but it has some perks and advantages. In universal fine-tuning, it can be tough to calculate and defend odds and probabilities. People like Barnes and Wesley do it, and I think their arguments are convincing, but the range of possible value, we don't know. We've got one universe. Sometimes atheists will make that argument. You've got a sample size of one. Nothing you say about probabilities has any value. It's irrelevant. Okay, but here, we've got an observable universe. We got huge telescopes. We've done star surveys. We found all the quasars that aren't blocked by the cosmic microwave background radiation. So we can actually estimate occurrence probabilities, and they could be compelling because the sample size is finite. We have the denominators. Here are some of those numbers. Number of galaxies in the universe? Let's give it 1 trillion. It's probably a few hundred billion, but we'll go ahead and round up for the atheists. So that means the number of stars is a few hundred billion there. That's 10 to the 23rd, so that's what? Nearly a trillion. And then let's say there's 10, we've got 10-ish planets sort of thing. If we cut the dwarf planets and some of the asteroids and stuff that could have moons, could be way bigger, but I don't know. 10 trillion planets, universe, rough guess. When you heard the words habitable zone in the past, if you've looked into this at all, it simply means right distance from host star. Planet at the right range of distance so that the temperature on the surface might be between 0 and 100 Celsius. Liquid water could be there, and liquid water is the prerequisite for all life as we know it, and that's it. So the scientific community, that is what habitable zone means. Further research by other scientists, this will be controversial. Some scientists will say, no, I don't think that's true. And others will say, yeah, for sure. There's an ultraviolet habitable zone. It's not the same place. Because the photosynthesis won't work if you're a certain distance away because of the flux of ultraviolet radiation and other things. A tropospheric ozone habitable zone has to have certain features. The rotation rate of the planet has to be in a certain range. The axis tilt of a planet can't wiggle around. Like Mars goes from 0 to almost perfectly sideways and back all the time. No chance for life. Tidal forces, astrosphere, atmospheric electric field. Venus has a huge one. There's no way it ever had life. Milankovitch cycles of varying obliquity and eccentricity and precession of a planet will kill life on it. The star is super important that you're around. Stellar magnetic wind. And cosmic temporal, at what point did the planet form in the universe? Had there been enough supernovae around to seed it with the uranium and thorium that would be required to maintain heat inside a magnetic field and plate tectonics that we think are essential to life? The supergalactic and galactic habitable zones. You got to be in a special spot in the universe relative to what's nearby on large scale. So you got life as we know it. You got to, wherever that is, it has to reside and satisfy simultaneously all 14 of these habitable zones. Probably no surprise, you're going to hear me say, guess which one planet is the only one we found that satisfies more than 2 of these simultaneously. So how did we end up here, and what are the odds of it happening by chance? I'm going to very quickly just show some pretty pictures and outline. From big to small, the Laniakea supercluster, our local Virgo supercluster, we're living on the edge. If we weren't living on the edge, wouldn't be here talking about it. The Milky Way, our ideal locale in a surprisingly stable galaxy. Our sun, which is relatively cool, calm, and collected. Our moon, an unlikely early collision, yielded a just right companion in our Earth. Insane mix of position and ingredients, and so we've got life here. Its source document is one of these books here, and this is updated routinely, but it's just giving the form of, these researchers will identify like a requirement and then estimate an odd. There's clearly uncertainty on these, but it's just a order of magnitude guess. Like variability of local dwarf galaxy absorption rate. 1 in 10 galaxies would have that present. So that's why there's a 0.1 there. Just going to show a few. So here's our neighborhood. Ever seen this before? Okay, cool. Something new. At least this was new. There are millions of galaxies with the different colors. It's kind of like a heat map, right? So the Virgo supercluster has this massive concentration of galaxies there. Our little local group of galaxies is right on the edge. We are gravitationally bound to that Virgo supercluster center, but we're way out here and we're on the outer edge. We're not in the green. We're like near a void, which would be bad, but not in the green. That was a really unscientific way to say that, sorry. But our local group, we are on the outer fringes of the Virgo subcluster, which is on the outer fringes of the Laniakea supercluster. So we're at the perfect spot to avoid lethal radiation and cosmic rays. Galactic nuclei, all these galaxies have supermassive black holes in them. We know that now. They're just cranking out X-rays and gamma rays. You're in the mix, you're dead, you're dead. They're just, so there's, I don't know, trillions of planets probably in these areas. They're done. They're just not going to be life because of their position. Then a little closer to home. Most little local clusters have large galaxies that are just a few galactic diameters across, but we don't. The Milky Way is about 100,000 light years across, and so is the Andromeda galaxy. But we're 2 million light years apart, so we're not influenced by the gravity. Our stars and planets that are orbiting them, if you had another large galaxy right there, which is usually the case, the gravitational dynamics and also then the radiation could be deadly. It's an oddity. It's rare to have that sort of local group. And you have to have a spiral galaxy that's stable. And you need dwarf galaxies. There's many more around here. We now know from simulations, if you're going to stay stable as a spiral galaxy for over 3 billion years, you got to keep gravitationally ingesting dwarf galaxies. So say the simulations. So here's the numbers, and I'll have a few slides like this that I'll go very quickly. In that particular approach in these books, by Reasons to Believe, they'll cite bunches of parameters. 99 parameters, here's a couple of them. A distance from the nearest giant galaxy. That's not super rare, there's a 40% chance. But then the density of dwarf galaxies near you that you eat up to stay spiral, pretty rare, 2% chance. Blah, 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 do 99 of those, add some other math, and just based on our galaxy cluster, 1 in 10 to the 53rd chance. So says these researchers. Now how about our actual galaxy? We're about halfway out. 27,000 light years from the supermassive black hole in the middle. Obviously that's not a real picture of Milky Way, we haven't sent a camera up above it. But we have star catalogs, we know where all the stars are. We were probably born here. Again, so say the simulations. Because we have so much uranium and thorium in here, it couldn't have happened out here. There's not enough stars around with previous generations of supernovae. So we started in a, if we were still there, we would not be talking about it, we'd be dead. Way too close to the center of a supermassive black hole and way too many stars nearby to rip us out of orbit. So we probably started about 13,000 with this gas cloud before it collapsed, got polluted by up to 4 different types of supernovae, so we had all the life essential elements that could eventually support life. And then we got ejected out to the safe zone near the co-rotation distance, this little zone that it's this thing spins, of course, and all the individual systems spin. When you're in this area, you have very few crossings of the big spiral arms. A big crossing of your star system across the big spiral arm is potentially deadly because then you get close to other stars. And if you get close, their gravity is going to whip planets out into extra eccentric and might take you out of the habitable zone, just like that. Hasn't happened in 4.5 billion years. And so there's 200 parameters apparently by these guys. The distance of a galaxy's co-rotation circle from the center of the galaxy and the mass of our black hole. We got a baby black hole compared to others. 4 million solar masses is our black hole, but Andromeda's is 100 to 200 million. And that's more typical. So again, that's unlikely. So you can see the roll-up of one life-enabling galaxy in the universe, 1 in 10 to the 135th. And how many galaxies are there? I don't know, maybe a trillion. 1 times 10 to the 12th. And then our sun. Our sun's crazy. Online you'll hear people say, oh, the sun's just normal. Right, just G-type dwarf star. Any planet orbiting any of these, forget about it. Way too short-lived, way too bright, massive X-ray UV. And then 90% of all the stars in the universe are small. They're red dwarfs down here on the Hertzsprung-Russell diagram. It's not going to happen. They flare all the time, we now know, and their variation in luminosity is extreme. Will not have a host planet. So the range of stars with potentially overlapping just the first 2 habitable zones, water and UV, they're these main sequence stars. And in fact, we're starting to think that even the slightest different mass of a star is going to make it deadly to life. And then the moon formation event, again, computers have suggested that the only way we have this moon is if a protoplanet smashed into the proto-Earth about 100 million years after the formation of the solar system. Just the composition of the current moon and our crust and the elemental abundances suggest this. So this planetesimal called Theia collided with the proto-Earth 100 million years after solar system formation. And what's nuts is modeling that event also shows that thing was fine-tuned. It's a rare event in the first place that a Mars-sized baby planet would smash into a larger baby planet. But the mass of the collider had to be in this tiny little range. The impact angle, there's almost no tolerance to get just not a disaster. And the collision velocity had to be really slow. So they were almost going the same direction. Most asteroids and meteors are going way, way, way faster. So some quotes in a paper is 13 years old, but it's still relevant. Current theories on the formation of the moon owe too much to cosmic coincidences. These are not theists. And the sequence of conditions that currently seems necessary in these revised versions of lunar formation have led to philosophical disquiet.
Not easy there.
Interesting. So, whatever, our moon, 1 in 10 to the 16th isn't a huge thing compared to the previous 2, but still 110 billion trillion. And then our planet, won't even get into it. There's a couple of options. The ovalness of our orbit can't vary by too much, or you get too hot or too cold, weather would be crazy. The surface gravity is 2 to 1 part in 1,000, just to keep the exact right mix of gases not escaping into space. And so the Earth, with its 268 parameters identified, is a 1 in 10 to the 281st power. And so here's the just ridiculousness of the roll-up numbers. Bacteria, 1 in 10 to the 311, 10 to the 556 for unicellular life for a few billion years, and then us, 1 in 10 to the 1032nd power. Doesn't even mean anything to that point, really, right? It's effectively 0. This is assuming chance, just with the naturalist model, random things happen, And here we are. Now for the rebuttals to the Earth-based, like Earth being having life one. Carbon chauvinism. Hey, why do you think water requiring carbon-based life is the only form of self-replicating stuff in the universe? There's no reason there couldn't be other kinds of life. Anybody ever heard that? You heard that, Claire? Huh. There could be other kinds of life. Let's investigate that. It was actually the focus of a Star Trek episode back late 60s.
Silicon-based life form.
Silicon-based life form. You know that? Yeah, so this is the silicon-based life form the crew of the Starship Enterprise encountered on some planet on a show. Why did they say silicon-based? It's for good reason. Carbon's this special element with exactly the right number of electrons to make all these life-permitting molecules, because it looks so great. Silicon's just below it. That's why. Silicon's your next best bet. If there is not, you can jump in here anytime.
Yeah.
That's my understanding as an astronomer about your realm. But silicon's the closest atom, and there's a study done recently. Yeah.
Yeah, my initial problem with this is just I know a lot about geology.
Geology.
Petroleum.
Yeah.
Silicon is like the most abundant element in the crust.
Yeah.
It is-
Aluminum silicates.
Yeah.
Yeah.
So if it were possible to have silicon life, we would probably have it.
Good point. I never thought about that before.
Yeah, like all like sand and all that stuff is like
So abundant.
Yeah.
Agreed. So at MIT, these are some, actually Sarah Seeger is a pretty famous scientist. The others are probably too, I just know about her. Did a study in 2020. Could it work?
I wanted to say that this was actually originally told to me by my mom. We exhale carbon dioxide, and the equivalent for a silicon-based life would be silicon dioxide, which is sand.
Yes. A problem. Perhaps that's one of the problems that led these in this abstract is this line. I'll just make a little bigger. In no environment is a life based primarily around silicon chemistry a plausible option. It just isn't. And that's the best bet for other kinds of life. So if you ever run into somebody who's like, they're just speculating, and it's actually kind of disproven scientifically that that's a viable claim. So bye-bye with that one. How about puddle thinking? Anybody heard of the puddle analogy? Jason has? Here's it in essentially, you'll see atheists on YouTube use this all the time. So a puddle of water looks around and says to itself, wow, look at this hole. It fits me perfectly. It must have been designed just for me. Thus, the universe wasn't designed for life. Life adapted to fit into the universe. Theists are crazy. So this is the book by Luke Barnes and
Good one.
Grant Lewis. The response to that one is, the extremes of parameter space are not just hot and cold. Rather, they're disintegrating atoms, the cessation of all chemical reactions, the crush of a black hole, and the eternal loneliness of life in a universe where particles collide every trillion years or so. Addendum, even if this were valid, like, oh, a life just will adapt to a little bit colder, a little hotter, a little more saline oceans or something. No. My opinion is the ability of any conceivable form of life to adapt to extremely different conditions that would have existed with different physical constants is likely very limited, even with the most optimistic versions of abiogenesis and evolution. Forward, you can't claim the universe is fine-tuned. 99.999 forever % of it's hostile life. And B, if God really designed the universe, much more, if not all of it, would be habitable. Or he would have made life able to occupy and survive a much wider set of environments. He's God. Okay, here's the problem. The first one, it fails to contest any premise of the actual fine-tuning argument, which only says physical constants have values that lie in an exceedingly narrow range that permit life to exist. Not the whole universe was optimally designed for life to achieve maximum abundance and spatial occupancy. That wasn't the point. And then for B, say, universal habitability, like why can't life live everywhere? Why would it be constrained to this one tiny planet? As the best design is a personal preference of the atheist, not some sort of obligatory goal for a designer. Fragile life forms and limited habitability are perfectly allowable features for divine design. And as we'll get to, that seems to be the point, as articulated directly in a very important book. And finally, it's arrogant to think the whole universe was designed for life and ultimately human life to exist. We're not special. That's a fact well established since the Copernican Revolution. And what a waste of space!
Yeah.
So, bro, at this point, given all available knowledge and data, the human brain is the most complex thing in the universe. And finally, we get to we're Ratio Christi. The Judeo-Christian worldview source document says we're special. Lots. So the Bible repeatedly conveys that God created this universe out of nothing, space-time, matter, energy, laws, and constants, and that human beings are the ultimate purpose and culmination of this design. You might think arrogance is appropriate. I mean, I don't want to use the word arrogance, I guess, but the point is, the Bible is true. We are the point. And there's tons of verses to talk about. So just a quick run. First, God created this. Right, the first verse of the whole thing. A little later in that chapter, so God created mankind in his own image. In the image of God, he created them. Male and female, he created them. And then, right after that event, God saw all that he made, and it was very good. Lots of verses like this. I just picked the one that kind of highlights how important we are to the creator of the universe, to the Bible. In Luke, indeed, the very hairs of your head are all numbered. Talk about every single human being on the planet and head who has ever lived. So don't be afraid. You're worth more than many sparrows. Sparrows come up because of what was spoken about in the previous verse. But then ultimately, probably the most famous book in the Bible, or famous verse in the whole Bible, John 3:16. God so loved the world that he gave his one and only Son, that whoever believes in him shall not perish but have eternal life. That's kind of validation. We are special. Like, weird. Doesn't make sense, right? That was God's choice. So waste of space, we actually know from simulations now that given the laws and constants of this universe, if they were chosen by God to be, that pretty much every minute of time, every milligram of mass, every square inch of space was required to yield a planet capable of supporting these 9 million species of plants and animals and our technologically advanced civilization of 8+ human beings. My analogy is more personal. In 2020, last time I gave this talk, my daughter had a birthday in November, and parents were freaked out about little girls going into a basement and playing games and stuff, even with masks. So we're like, okay, this is how much we love our daughter. We could have just been like, throwing a cupcake with a candle on it on a table out in the front yard and had her friends drive by, and be like, happy birthday. But no, we built a whole princess palace out in the backyard with rugs and then crafts and gave them stuff to do with their masks on that they loved, and we didn't have to do any of it. We could have satisfied the requirement by saying, happy birthday, here's a cupcake. But because of how much we love our daughter, we went bananas to show her how much we loved her in a way, and wanting her to be happy and fulfilled and have purpose and have relationship with her friends. We put in hours and hours and hours and a few $100. You call that totally unnecessary, but as a father to a daughter, that was the right thing to do, right? Anybody who has kids, it's just impulsive. You almost can't help it. And I think it's a real analogy of our Heavenly Father. And yeah, could he have done this differently? Sure. Just made an earth, made it habitable. None of this other stuff. Just like Karen's. It's a specific thing guiding us to truth, keeping us on the path. He says, I make the heavens declare my glory. The skies proclaim the work of his hands. Day after day they pour forth speech. Night after night they reveal knowledge. Since what may be known about God's plain to all of us, because God's made it plain. For since the creation of the world, his invisible qualities, eternal power and divine nature have been clearly seen, being understood from what's been made. So that people are without excuse. And then about the laws of physics, this is the one you usually go to about most specifically saying, this is what the Lord says, if I have not made my covenant with day and night and established the laws of heaven and earth, then I will reject the descendants of Jacob. David, my servant, will not choose his son to rule over the descendants of Abraham, Isaac, and Jacob. It's essentially saying constant, divinely established principles that govern the universe. And these laws reflect a logical, orderly creator rather than a chaotic, accidental universe. That was an option, but he chose to to make it orderly. So what model best explains the data? Finally wrapping it up here. Chance, I like to call this the Lloyd Christmas fallacy. It was a great question on the poll everywhere. Does anybody know who Lloyd Christmas is?
Oh yes, I've seen this movie.
Oh yes. Do you know the line that's gonna come up on the little meme I put up in a
Yes.
second? What is it?
So you're telling me there's a chance?
Oh!
Yeah.
He nailed it!
Right.
Yes! Nice. Of course, Jim Carrey, very interested in Mary Swanson. Knew it started with an S. And he says, what are the chances of a guy like me and a girl like you? Actually, he says, a guy like you and a girl like me. It's like 1 in 100, she says. Or like 1 in a million. He says, so you're telling me there's a chance. If I had the internet, I would have shown the clip. So that's where either the multiverse or the, hey, don't ask, we're here, 100% chance we're going to be here. Then necessity, hey, someday we'll learn the universe had to be life permitting. Those are 2 options. Or design. The life permitting features reflect contingency, complexity, and specificity. The ultimate goal actually was from a divine designer, and this is the home for the image bearers to survive and thrive. So bottom line, fine-tuning is not a slam dunk. It won't convert anybody, probably. But it's really intuitively compelling to most people. That's why the atheist scientists say it's like the biggest tool in the toolkit and seemingly most compelling. But combining it. So you combine that with cosmological argument, moral arguments, and others, and it's just really, at least I know for me, I suspect many of you in the room, a very compelling support to our faith. So looking ahead, hey, when will science finally prove naturalism's wrong? Spoiler alert, never. It's just not going to happen. It can't happen. People will remain optimistic about the origin of life and about the future science that will just reveal the theory of everything. And they'll choose that over the truth of God. No matter how much data piles up, or how implausible, or how impotent the explanatory power is of it. But we can and should continually assess ongoing research and just assess and talk to people about it. Does new data show Earth is typical and life common across the cosmos? If that happens, go for it. Yay, naturalism, way to go. That would be points for naturalism. But if the mounting evidence, which has been the case over the last few decades, indicates Earth and life are rare or possibly unique, it's kind of objective. That scores points for theism. That's where I got most of my stuff from for this one. I'd never even found these 2 guys on YouTube before, but they had some pretty good rebuttals to atheist objections to fine-tuning videos. They do a way better job than me, but thanks for coming. I know this is a crazy week for you all, and you took the time to be here. Kudos. Hope it was interesting.
I think we have about 10 minutes for questions.
Sweet.
Do that.
What's up?
When you were talking about our distance from the center of the galaxy,
Yeah.
what was wrong with, or what would be wrong with our solar system being further out from the center?
Show it. Show a pretty picture. The main problem with being further out, there's 2. If it was born further out, the sparsity of stars throughout the galaxy's history would mean that the number of supernovae that would have occurred up to that point would not have yielded a dust cloud with the correct mix of carbon, oxygen, nitrogen, phosphorus, uranium, thorium, etc. You would never have enough to make life. If you are there now,
Yeah, that's
let's
what I'm
say
wondering.
the other scenario, the solar system was born here, we got the right ingredients, we got life, but the migration ended up here. The speed of us going around with the speed of the spiral arm velocity means we'd essentially cross the spiral arms much more often, which would increase the likelihood of having a closer star flyby to our sun and our planets. And it's just because it doesn't take much, if our orbit of our Earth around our sun were to get a little more, just slightly more ovally, then it would whack out our climate and probably generate mass extinctions and perhaps full extinction of all life. That's the idea. With the galaxy position. Good point about silicon. We'll see though. In the next few years, the James Webb Space Telescope will continue analyzing the atmospheric content of exoplanets in our local neighborhood. If they find one with a lot of methane, you're going to see the headlines. They're going to be like, there's no other way there could be this much methane. There's for sure life on that planet. Hold on.
As a thinking with the Big Bang, like one question I always like to ask atheists is, okay, how did that matter come into existence then?
God, thank you. From my core.
And of course they can never answer it.
That's right.
And they'll always just ask, well then who created God? So it happens every time.
I ran into that in researching for this talk, that rebuttal of, well, if God designed the universe, who designed God? And that's a shell game because it's useless because at some point there has to be the end of the regress. There has to be the start designer.
Yeah.
And it doesn't like affect the power of the argument of a designer by asking that question. It's a total distraction. But you're right, but they won't realize that. It's okay. Still, it's the right thing to state and see where the conversation goes.
I just feel like they don't really. I just feel like that those atheists who say that science is always right are hypocrites. They'll talk about the laws of science and yet they'll reject conservation of mass. That everything had to come into existence.
Good point.
So science has been wrong so many times.
Yeah.
Just there's a really long list of times the scientific consensus has been just dead wrong.
And that's an interesting thing to consider as well, because even as I'm talking about this stuff with pretty high confidence, readily admit, so that cosmological constant thing is the influence of dark energy. That word dark energy is an indication of how clueless we are about what it is that's driving the expansion of the universe accelerating. And thus, I feel a little sketchy sometimes putting that up because we're so clueless about the mechanism that's driving that. How can we claim this fine-tuning of it? But then I go, well, this model, this cosmological model with these very exquisite equations that have been run through supercomputers zillions of times have revealed that is the case. And at the moment in history of scientific exploration, this is the best answer, and that is the most confident, true thing we can state. But I do like that if you're having a conversation with atheists, I think it's genuine to articulate, we don't know for sure. It's just, what are you gonna do? You could just walk around being like, we don't know anything. Let's go to lunch. But everybody in this room is not designed that way. Otherwise, you wouldn't be here. You wouldn't be satisfied with that answer. But yeah, it's a good point.
I guess in your work, what is the most common objection that you see personally, talking to maybe colleagues or otherwise?
Well, I think I haven't been in, I'm just messing around teaching high school and selection and planetarium now. So my deepest dive into real academia was as a graduate student at the University of Minnesota for 3 years. And in that lab, I was, of course, the only Christian of 8 grad students and a couple professors, mentors. And it was a cosmology lab. So we're trying to prove that inflation occurred by way of some data from cosmic microwave background radiation. So the origins thing would come up. It rarely ever came up, though. I mean, they don't care about talking about it. We're there to publish papers and try to get a telescope to work. But on the occasional social outing while we're doing research in New Mexico or whatever, if anything like that came up, it would be the cosmological argument part and not thinking there was a problem with space-time, energy, and matter popping out of nothing. There's always an excuse. And some would be aware of like Lawrence Krauss's hypothesis that quantum fluctuations are plausible. We do have virtual particles that have been validly pop into seeming out of nothing. Virtual particles pop into and out of existence. That is an experimental fact. But then the jump to, well, that's probably what happened with our whole universe. To me, it's like, whoa, no way. That behavior that is observed here in our universe today requires the laws of quantum mechanics to exist. This universe coming out of not even any laws existing just isn't plausible. But to that group, it is, and I think it's largely not because they really buy it fully, it's just there's no other option. If you've a priori committed it to there is no God, that's the best game in town. So you got it. You got to go with it. That's it. For now, until Cross writes another book or, whoever, Dawkins or somebody comes up with another idea that they'll publish on YouTube for the next 10 years and then it'll fade into obscurity because it will be clearly proven false. But there'll be a never-ending supply. And ultimately, the enemy has got the army of distractors in all communities, including the scientific community, that will continue to distract with ideas. Hey, that's it. True. He's got homework. He's got project. You got project what? More interesting than astronomy.
I don't know about that.
It is about business, I suppose, right?
Somewhat.
Some business.
I think if no one has any more questions, we can give a round of applause. I guess I can just close this from here. Just thank you again for coming and presenting. It was awesome, as always. Again, announcements. Next week is Carl talking about mosquitoes. Do you want to give kind of a preview on what that's
Well,
gonna
so here's the thing, and you put up a verse. God said his creation is good. And then we have, there's a verse in 1 Timothy that says everything God has created is good. And then we got mosquitoes. So I guess the first question is, do we have any evidence that God created mosquitoes in the first place, or does God get a pass? We can explain mosquitoes away that way. Or, if not, how can we reasonably say that mosquitoes are good? So we'll chase that a little bit. See if there's evidence that God created mosquitoes, and why would the Bible be able to say something like mosquitoes are good?
Okay, and this man knows a thing or two about mosquitoes. I believe you got your graduate degree.
Yeah, I have a graduate degree in entomology. My research was with mosquitoes.
So definitely come for that, because got the mosquito expert in town.
Yes.
So I think I'll pray us out, and then after that, feel free to grab some more snacks. Those cookies are delicious. If you haven't had one, they're amazing. Thank you, Heidi. Yeah, I'll pray us out. Dear God, thank you for just allowing us to have this time out of our week where we can come and learn about your creation and just how wonderful and precise you've made it. I pray, God, that you continue to just grow our knowledge of you and help us praise you for how you've made the world. I pray that you help us also understand that you made us special and that you love us, and it's not just a cold scientific fact, but a intimate personal one too. That you sent your son to die for us because you love us. And I pray, God, that that is something that we always just keep at the forefront of our heart and mind. I thank you again for Dr. Polsgrove and just allowing him to come here and give this talk. And I pray that you give us opportunities to use what we've learned in the future. In your holy name I pray. Amen.
Amen.
Righty.
Yeah,
Thank you again.
of course. See you next spring, hopefully. Hopefully I get permission again next spring.
Hopefully so.
One last time before you graduate, Grace.
Yes. Gotta do it.
Hey, thanks. The royal flush guy.
Royal flush.
You gave it back.
Lucky day. Yeah.
And
Was I
then
convincing with the shuffle? The big shuffle.
chocolate and
You could probably tell I wasn't shuffling the top ones, right? Why you're too close.
Put in some work.
Super bad hand. You could have chased that straight. Just needed a 6.
I've been wanting to try it for a while.
Playing poker too?
I have played some.
How? Like online or
Just in person here. Not betting anything, just really
just like in the dorm with
Yeah.
my friends or whatever? That is fun.
I think the best thing I got was just a full house once.
Yeah.
I have gotten a royal flush once.
No.
Really?
By chance or did you cheat?
It was by chance,
Nice.
but I
You're
think
going
there's
around
enough hearts because like there's 4 different suits that
Yeah,
I
and
the
there were
number down a
people-
bit.
Yeah.
There might have been some poor shuffling as well.
But it wasn't a check, it was American law.
But yeah, I was like, well, also you have to remember when
What I
poker
do
is
is I send out
instead of 5.
He did
And
a
that
series
really awesome.
Friday.
of demonstrations
Yeah. You play that.
where
So-
he
Yeah, so it's I think maybe
basically sterilized a
1,000,
his broth
and then it's like I played maybe 100 rounds of poker,
and then had that same
yeah,
broth.
it's interesting.
Yeah.
Yeah, I know when I was like a kid, I watched like
And nothing grew
like
in the sealed container.
I don't know, it wasn't very much like a normal game. I was like
Okay.
watching stuff like documentaries.
So the bacteria that's growing in this
Yeah.
container
Also, like,
had to come from somewhere.
RDIS.
Because the
Any
previous
kind
idea was you had this spontaneous generation.
Yeah.
If you just have the right materials there, it'll just,
you know, kind of familiar with this.
yeah, right.
I think it's fascinating how
Yeah.
that and, Darwin's Origin of Species.
You majored in geology, huh?
Petroleum.
And
Petroleum.
germ theory of
Your
disease
major
was
petroleum.
getting
Petroleum.
batted around the same time. And it seems to me that evolution was accepted.
Master's degree, actually.
And the germ theory of disease took 100 years to be.
Darwin's theory.
Where did you go for undergrad? Here too? So did you
Pretty
get away?
Nope. Yeah, I
Say
can't,
that
I
it
cannot
was
escape.
7